Okay, so in this video, we're going to talk about what is the domain of a function and how to find it. So here we have a function f of x equals x minus 1 over x squared minus 81. And the way I like to think of domain is if you were, let's say, trying to graph this function, and sometimes when you're graphing a function, if you're not sure what it looks like, you can always make like a little t-table where you pick some x values and then try to plug them in to see what you get for your function. So, say you were to plug in, maybe we start with like 3. What would I get? I would get 3 minus 1, which is 2 over 3 squared, 9 minus 81. I think that would be negative 72. So I'd have that as a y value. You could plug in 1, for example. If you plug in 1, you end up with 0 over negative 81, which is just equal to 0. But what happens for certain numbers, if you were to try to plug in 9, of course, 9 minus 1 would give you 8 on the top, but in the bottom, 9 squared is 81 minus 81, you would get 0 in the denominator. And remember, a fraction where the 0 is in the denominator is undefined. You would not be able to plot that point. So we would say numbers like 3 and 1 are in the domain. These numbers are in the domain. And a number like 9, and maybe you're thinking of another number that would not work, is not in the domain of our function. Okay, what's the other number that you could square and get 81? Well, negative 9 would not be in the domain as well, right? You would end up getting the same thing. So when you think of domain, kind of just a simple definition of what domain is, domain are the x values that you, how about we put quote unquote, are allowed to plug in. So if you have a number that's going to make you divide by 0, then that would not be allowed. Now, how would I find that? In general, if I've got a fraction, then how would I get these numbers? I know that I'm not allowed to divide by 0. So if I have a fraction, what I'd want to do is focus on that denominator. Cannot divide by 0. So we're looking for numbers where x squared minus 81. Well, if we can't divide by 0, we don't want that to equal 0, which means x cannot equal plus or minus 9. So in interval notation, every other number is okay, right? So if you think about on the number line, what numbers are allowed to plug in, because that's what the domain is. These are what can't be in the domain, but we need to specify what the domain is. We're basically talking about the entire number line except for those two numbers. So in interval notation, this would be all the numbers from negative infinity to negative 9, not including union the numbers from negative 9 to 9, or the numbers from 9 to infinity. This would be my domain. So yeah, one thing to think about is if you have a fraction, you want to focus on the denominator and make sure that your denominator never equals 0. What are some other functions that could present issues with domain? If I've got a function with a square root, remember that you cannot take the square root of a negative number, right? So how about we put this? If we have the square root of some stuff, what has to be true is whatever is under the square root, whatever kind of numbers are inside that square root, has to be greater than or equal to 0. Right, that's just because you can't take the square root of a negative number. So for this function, I know I could plug in certain numbers, but there are going to be numbers that are going to make this square root generate, and this force me to take the square root of a negative number. So my starting point would be x minus 4 is what I'm taking the square root of. I need to make sure that that's giving me numbers greater than or equal to 0. x minus 4 is greater than or equal to 0 just tells me x is greater than or equal to 4. As long as I use numbers 4 or bigger, I can plug it into this function both here and here and expect to get an answer, to get a number. So my domain here on the number line, of course, these are all the numbers greater than or equal to 4 would be any of these numbers. So in interval notation, we've got bracket 4 all the way to infinity. Well, we can't divide by 0. You can't take the square root of a negative number. Sometimes we have functions that have both of those issues here, right? So this function is the square root of x plus 2, and then not in the square root, divided by x minus 7. So if you've got two issues to think about here. This square root of x plus 2, I know that the inside here, x plus 2, has to be greater than or equal to 0, which is easy to solve. That tells me x has to be greater than or equal to -2. But I also have to have, I can't divide by 0, so I know that x minus 7 cannot be 0. X cannot be equal to 7. Your domain needs to satisfy both of these, right? We can only plug in numbers that are greater than or equal to -2, but not equal to 7. We can illustrate that on a number line. We could say, here are numbers greater than or equal to -2, but at some point I'm going to hit that 7, and I just don't want to include that. I can plug in 6.99 or 7.01. I just can't plug in exactly 7. So that would just be an open circle on the 7. And my domain would be from -2 including to 7 not including, or from 7 to infinity. More examples. So f of x equals 1 over root x plus the square root of 1 minus x. So the issue on this first one is I do have a square root, but it's also in the denominator, right? So we have to kind of think about both of those. Just for the square root, I know that x has to be greater than or equal to 0, but I also know that x cannot be 0, because if x was 0, I'd be doing 1 over 0. So if I combine those together, if x has to be something greater than or equal to 0, but also not equal to 0, what that means is x has to be greater than 0, not including. For this square root, I need to make sure that 1 minus x is greater than or equal to 0. You can either, well, the way I do algebra, I would add the x over to the other side. And if you read that from right to left, that says x is less than or equal to 1. So let's think about these numbers on a number line. Numbers that are bigger than 0, not including, would be over here, but also less than or equal to 1. That means I want numbers between 0 and 1, not including the 0. So my domain would be open parentheses 0 to 1 closed. Okay. Also should mention, I talked about you can't take the square root of a negative number. Remember, that's true for any even number. So if you have an even root, a square root, a fourth root, or a sixth root, that cannot take an even root of a negative number. Think about it. If you try to do the fourth root of -1, there is no number multiplied by itself 4 times that could give you a negative number. So that would not be allowed. Same thing with like the 6th root, that would not be allowed. And certainly the square root of -1 is not defined unless we get into imaginary numbers, which we're not going to. So, so then I have a fourth root of all of this stuff. And so for my domain, I need to make sure that when I plug in x values, that x squared minus 12x plus 32 is giving me numbers greater than or equal to 0. Okay, now this is something we've done before. This is now an inequality that we have to solve. Remember, for a quadratic or a nonlinear inequality, you're going to want to factor this. Numbers that multiply to positive 32 add to negative 12 would be x minus 4, x minus 8. And remember, this is the tricky part. You don't want to set both of those greater than or equal to 0. You've got multiple factors here. If it's an inequality, this is when you want to use the number line, not to illustrate your answer, but to actually figure out where this expression is greater than or equal to 0. So this is the one where you're picking test numbers in each region. So a number less than 4, maybe 0, something between 4 and 8, how about 6, and something bigger than 8, how about 10? And if you plug in 0, 0 minus 4 would give you a negative number. 0 minus 8 gives you a negative number. A negative times a negative is positive. 6 minus 4 is positive. 6 minus 8 is negative. Positive times a negative is negative. And if x is 10, that would be positive. The second factor is positive. So when I multiply them together, that'll be positive as well. Greater than or equal to 0 means I want the positives. So I would want all the numbers to the left of 4 and to the right of 8 in interval notation. That's negative infinity to 4 bracket or 8 bracket to infinity. Okay. Another example, f of x equals the square root of x plus 3 over x minus 5. Kind of looks similar to one we did earlier, but the one we did earlier, only the x plus 2 was under the square root, not the x minus 7. So we just had to set what was under the square root greater than or equal to 0. So here, this whole expression has to be greater than or equal to 0, right? This whole fraction. So x plus 3 over x minus 5 is going to have to be greater than or equal to 0. Notice we also do have a denominator, right? So what else has to be true is this denominator right here cannot be equal to 0, which means x cannot be equal to 5. Okay, so we'll deal with that in a second. What I wanted to remind you of is, just like the previous problem, if you multiply two factors and it's an inequality, you need to use the number line. Same thing if you're dividing two factors. In order to sort this out, the best option is to use the number line. So I want to have negative 3 on my number line because that makes the top 0, positive 5 because that makes the bottom 0. And let's deal with this right now. Greater than or equal to 0 means I want to include, right? I want to include the numbers, and I will on the negative 3, but I can't on the 5 because if x is 5, my denominator is going to be equal to 0. Notice if x is negative 3, what do I get? I get 0 over negative 8. And 0 over negative 8 is equal to 0, and 0 is greater than or equal to 0. So that's okay, just not on this one. Okay, then I just pick some test numbers. Maybe negative 10, 0, positive 10. Negative 10 minus, no, negative 10 plus 3 is negative. Negative 10 minus 5 is negative. Negative over negative is positive. 0 plus 3 is positive. This will be negative, so the quotient will be negative. X is 10, both are positive. And I want the positives, so we would have negative infinity to negative 3, including or not including 5, all the way to infinity. Okay, a few more examples here. Here, f of x equals 1 over 1 minus 1 over x. No square roots this time to worry about, but hopefully you see that not only I have two denominators I have to worry about here, right? there's this denominator. I need to make sure that 1 minus 1 over x does not equal 0. But I also have, just from this little fraction, this denominator, which is easy. That just means x cannot be 0, right? I can't do 1 over 0 there. So I have to just deal with both of those. This one isn't too hard. 1 can't equal 1 over x. What's the only number that would make that equal to 1 is if x is equal to 1. So here my domain, I can choose any number I want, just can't be 1 because it makes the big denominator, the entire denominator, equal to 0, and I can't choose 0 because it makes this little fraction undefined as well. So my domain, any number except for those, would be from -infinity to 0, not including. Don't forget, between 0 and 1 is fine. And then numbers from 1 to infinity. Okay, similar kind of a thing going on here. Remember, numerators, don't worry about numerators. Numerators can be equal to 0. If x is -1 and I get 0 in the numerator, that's fine. It's just denominators that can't be equal to 0. So one thing to think about here is 3 minus the square root of x cannot be 0. And you can't take the square root of a negative number, which means just this little x has to be greater than or equal to 0. Solving this is the equivalent to saying the square root of x cannot be 3, which means x cannot be equal to 9. So if I want all the numbers greater than or equal to 0, but not 9, that means I want the numbers from 0 to 9 parentheses, then go on the other side of 9 all the way to infinity would be my domain. Lastly, for this last function here, I do have a radical and I do have a denominator, but the difference here, I've given you some square roots and some fourth roots. Remember that you can take the cube root of a negative number is totally fine, is okay, is possible. For example, remember that the cube root, for example, of -8 would be -2 because -2 times itself 3 times gives me -8. Okay, and that's true for any odd roots. If you did the fifth root of -1, that would be -1 because you multiply -1 times itself 5 times, you will get -1. So with odd roots, the inside here, there is really no restrictions on that. You can take the cube root of a positive number, a negative number, 0. This is totally fine. So I don't have any issues to worry about here. Maybe we just say for this right here, this part right here, x can be any number, right? X equals any number. Now I do have a denominator, and we've seen when we have denominators, we have to worry about denominators equaling 0. I usually say does not equal 0, which is like saying x squared cannot equal -9. Well, if you think about that, is there any number you could square and actually get it to be -9? There's no number that's going to solve that. So we could say this is true for all x values. Let me move that up. In other words, you can plug in anything you want here. Any x will work, and you're never going to be dividing by 0. So, you know, after doing 8 problems in a row where you couldn't just plug in any number to your whole function, I want to remind you there's plenty of functions that you can plug in anything you want for x, which means the domain is all real numbers. In interval notation, that's the entire number line. So your domain here would be from -infinity to +infinity. Hopefully you have a better sense now of what domain is and how to find the domain for different types of functions.